Hey everyone, Victor is here, and in this video I want to show you an easy synthetic strategy how to convert simple alcohols into more complex structures. As the prerequisite, you'll want to be familiar with the Grignard reaction, how to make alcohols via the Grignard reaction, and the oxidation of alcohols. So if you need a refresher, go watch those videos first and then continue with this one. So assuming that you remember all of your reactions, let's jump into our first example right away. Here we have this butanol over here that I'm going to be converting into a more complex alcohol. And by doing the quick analysis of my new structure, I can see that I'm creating a new chemical bond over here between my old part of the structure, the part which used to be my alcohol, and this new benzyl group that I'm attaching here. Now, since this new bond over here is a carbon-carbon bond, the most likely reaction that we are going to be using in this case is going to be the Grignard reaction, which is the premier method of carbon-carbon bond making. So, thinking about this transformation retrosynthetically, I know that my prerequisites or my precursors to this final product here would be an aldehyde looking like this and benzyl magnesium bromide as my Grignard reagent. Now, something that I want to point out, as I have mentioned before in my other tutorials, the carbon count is always a very important thing. So I do have this extra carbon over here, and this extra carbon is right over there in my Grignard reagent. Make sure that you do not lose your carbons when you are breaking your molecule apart, because then you are ultimately going to be shortening your reagents and just making the wrong compounds. So always keep a vigilant eye on your carbons, and if you need to, you can always number them as well. Now, coming back to my intermediates over here, I see that my intermediate here is an aldehyde, and the starting material is an alcohol. We can easily convert an alcohol into an aldehyde via the oxidation reaction, which means that we are essentially have reached our starting material point, so I'm going to show it like this in my retrosynthetic analysis. Now, as I've mentioned, the synthetic steps here are going to be the oxidation reaction to go from the primary alcohol to an aldehyde, and then to go to our final product, we are going to be doing the Grignard reaction using our Grignard reagent over here. So, assembling my synthesis together, I'm going to start with my alcohol, my starting material, and step number one here would be the oxidation to the corresponding aldehyde. So to make sure that I don't over-oxidize my molecule, I'm going to use oxidizing reagents like PCC, or I could use Swern oxidation, or maybe I could use Des-Martin per iodine here. Doesn't matter which one we are going to be using. The point here is to make sure that we are stopping at the aldehyde and not over-oxidize that to the carboxylic acid. Now, once we have our aldehyde, we are going to do the Grignard reaction, and we already know the reagent that we are going to be using in this case. It is going to be the benzyl magnesium bromide, so the Grignard reagent is going to attack our carbonyl, electrons go up, giving us the following alkoxide as an intermediate, and the new bond that I have just created is right over here, so I'm going to show it with an NB sign, and like with any other organometallic reaction, we want to protonate our alkoxide intermediate that we have here, so I'm going to do my acidic workup, resulting in my target molecule. Now, this one was a fairly simple example, but how are we going to deal with something a little bit more complex? So in this example, what I'm seeing is that I'm going to make two different carbon-carbon bonds, and since I'm going to be adding two different substituents, I'm going to have to do the entire sequence of the oxidation plus the Grignard reagent twice. And also because I have two different groups, I have a couple of potential options how exactly I want to do that. My first option, let's color code it in purple, is going to be making a bond between this vinyl group and the rest of my molecule, and my other option is going to be the one that adds the propyl group the last. Now, in both cases, I'm going to convert my carbonyls into the corresponding alcohols that would be predecessors to the formation of the carbonyls, and do this trick with the Grignard reagent one more time, now making this bond in the purple example and this bond in the green example, giving me the following intermediates. And as you can see in this case, I did end up with the same aldehyde in both cases. I have benzaldehyde in my purple scheme, and I have benzaldehyde in my green scheme, both of which would be coming from our starting material from the benzyl alcohol via the oxidation reaction. So let's shrink both of those retrosynthetic analyses here so I can actually write my synthetic schemes for each of those transformations, for each of those pathways. As my first option here, I'm going to go with the purple pathway. We are going to start with our starting material, with our benzyl alcohol, and oxidize it into benzaldehyde using PCC or any other oxidation techniques that you like that are going to stop at the formation of the aldehyde. Then we are going to react that with propyl magnesium bromide, followed by the acidic workup, of course. That gives us the secondary alcohol, which we are going to oxidize to a ketone again and do our final Grignard reaction here to get our target molecule. And my option 2 in this case is going to be my green pathway, which is going to start exactly the same way as the previous pathway with the oxidation of the benzyl alcohol to benzaldehyde. So I'm just going to copy that step over here. And then we are going to have another sequence of Grignard reaction followed by the oxidation, giving us the following ketone, which after the last Grignard step with the acidic workup going to give us our target molecule again. Now you might have a question here, which option is a better option? And in this particular case, like in most cases that you are going to see within the scope of your course when we are dealing with the Grignard reagent, both options are equally as good. So you could choose either the purple pathway or the green pathway here, it really doesn't matter, you are still going to get the same final product. There are of course some minuscule differences with the reactivity and how exactly you would do this reaction and yields, etc., but we don't concern ourselves with that within the scope of the introductory organic chemistry, so for our purposes here, both methods are equally good. So hopefully by now you are seeing the general pattern. We take the alcohol, we oxidize it, we do the Grignard, we oxidize it again, we do another Grignard depending on how complex our structure is and how many times we need to make new carbon-carbon bonds. So let's look at one more example just to solidify this skill. Now here I again have an alcohol, it is a secondary alcohol as a starting material, and I'm going to be creating a new carbon-carbon bond right over here. As per usual, I will just call it a new bond. Using the Grignard retrosynthetic analysis that I taught in my previous video, we are going to have cyclopentanone as our intermediate, plus the corresponding Grignard reagent. And of course, our cyclopentanone will be coming from the cyclopentanol starting material. So if I now want to assemble the synthesis together, I'm going to start with the cyclopentanol, do my oxidation with something like PCC. Since this is a secondary alcohol, it really doesn't matter what type of oxidation you're going to use, so you don't have to use PCC or Swern or Des Martin. You can use just a chromic acid or Jones reagent, whatever you like. It is a secondary alcohol, so it cannot be over-oxidized. But since I've been using PCC this entire video, I'll use PCC again here, which would give me my cyclopentanone intermediate. I will react that with my Grignard reagent, so the Grignard reagent is going to attack our carbonyl, electrons go onto the oxygen, giving me the corresponding alkoxide, and the new carbon-carbon bond that I have just created is right over here. And so the last step that I have left here is going to be my acidic workup that will protonate my alkoxide and give me my target molecule. So while these type of syntheses might look complicated, in reality, as you can see, they're just the repetition of the same steps over and over again. So remember, whenever you need to take an alcohol and convert it into a more complex alcohol where you have new carbon-carbon bonds, we are going to generally follow the same pattern. We will start with our alcohol, we will oxidize it to a corresponding carbonyl. Then we are going to do the Grignard reagent to make the next alcohol. If we need to, we are going to repeat this process by oxidizing it to the corresponding carbonyl and make a more complex alcohol. So if you are starting all the way from the primary alcohol and you are going all the way down to a tertiary alcohol, you will go through the the formation of the aldehyde, secondary alcohol as an intermediate, then you will have a ketone, and finally you will get to your tertiary alcohol. And as I have demonstrated with my examples throughout this tutorial, you can start at any point in this scheme, any point in this ladder, so to speak, and you can keep on going until you get to the product that you need. So now you'll know how to tackle a synthesis when you start with a simple alcohol and finish with something a little bit more complex. And as always, thank you for watching. If you learned something new today, synthesize that like button, subscribe for future updates, check out this awesome video next, and I will see you next time.